In 1885, at the corner of LaSalle and Adams in Chicago, workers finished a building that looked, from the outside, almost ordinary. 10 stories, modest footprint. But inside, something was different. For the first time, a metal skeleton, not the walls, formed the primary structural system of a tall commercial building. Cast iron columns, wrought iron beams, rising floor by floor, carrying the load. That building was the home insurance building, and the idea inside it helped launch a new era of construction that's still unfolding today. Chicago is known for many things. Deep dish pizza, Michael Jordan, hot dogs. The Windy City has always had character. Brutal winters and machine politics. Calling dibs on parking spaces that you've shoved out. A city of endless neighborhoods that has produced lasting ideas, industries, culture, and sometimes a bit of trouble. But perhaps its greatest contribution to the world was a new way to build, and it started with iron and steel. The story starts in October 1871. Over 2 days, the Great Chicago Fire burned through more than 2,100 acres of the city's core, destroying over 17,000 structures. But what the fire really destroyed was a way of building. Before 1871, Chicago's commercial buildings relied on timber frames and load-bearing masonry walls. They burned. And in the aftermath, new codes mandated fireproof construction. But masonry had another problem. The taller you built, the thicker the walls had to be at the base. The 16-story Monadnock Building, the pinnacle of masonry construction in Chicago, needed base walls nearly 6 feet thick. In a booming central business district, where every square foot of floor space was money, that was an enormous premium to pay. Chicago needed a better answer, and it turned out iron and steel could provide one. Wrap it in fireproof tile or terracotta, and you get a fire-resistant structural system without the bulk. The conditions were set. Now the material had to catch up. 3 developments converged in the mid to late 1800s that made structural steel viable at scale. The invention of the I-beam gave engineers a shape that puts material exactly where bending stress demands it. The Bessemer process made mass production of steel affordable for the first time. And the development of wide-flanged sections, pioneered at mills in Differdange, Luxembourg, and later brought to the U.S. by Bethlehem Steel, gave engineers consistent, predictable structural shapes they could actually design to. Chicago was perfectly positioned to consume all of it. Illinois Steel Company, Inland Steel, and U.S. Steel's massive Gary Works in Indiana put high-tonnage structural steel within a short haul of the loop. The geography made it almost inevitable. Iron ore arriving by ship from Minnesota, coking coal from the Appalachians, all feeding a city that couldn't build fast enough. With new codes, a blank canvas, and a material finally ready, Chicago's engineers went to work. The Tacoma Building in 1889 was the first metal frame with fully riveted connections. The Rand McNally Building in 1890 pushed further as the first building to achieve a truly all-steel frame. By 1895, the Reliance Building unveiled an exterior that was over 2/3 glass. What steel brought wasn't just height, it was the decoupling of structure from enclosure, and that single idea unlocked a new era of urban construction. Into the 1920s and early 30s, Chicago's steel frame skyline kept climbing. The Wrigley Building, Tribune Tower, Carbide and Carbon, Civic Opera, and the Board of Trade, each one a demonstration of how far the steel frame had come. But in 1929, the Depression brought construction to a halt. After the Field Building was completed in 1934, Chicago wouldn't see another major tower for over 20 years. The question wasn't whether Chicago had figured out how to build. The question was how far, or high, the system could still be pushed. The answer came back to Chicago in 1955 with a structural engineer named Fazlur Khan. Khan had just completed a PhD at the University of Illinois and joined Skidmore, Owings & Merrill's Chicago office. His insight was that conventional steel frames lose efficiency fighting wind as buildings get taller, and he set out to change that. The John Hancock Center, completed in 1969, was the first building to use Khan's trussed-tube system. At 100 stories, it used just 30 pounds of structural steel per square foot, the same amount you'd expect from a conventional 50-story building of its time. A massive leap in structural steel efficiency. Willis Tower followed in 1973 with the first use of the bundled tube framing system. At 110 stories, it held the title of the world's tallest building for nearly 25 years. Both buildings also benefited from advances in the steel itself. The Hancock used steel with strengths up to 46 KSI, Willis Tower up to 42 KSI. For context, the steel that built the Chrysler Building roughly 40 years earlier had a strength of just 30 KSI. The buildings got taller, the structure got smarter, the steel got stronger, and Chicago was the city that proved it. This didn't stop. Chicago's structural laboratory never closed. But today's buildings face a different set of constraints. Tight footprints, river setbacks, rail infrastructure, public space requirements. Structure can't always go where convention would put it. Solving those problems has required pushing steel itself further into higher strength grades and jumbo sections that were once unimaginable. Chicago's newest generation of towers has embraced these innovations and done it with A913 high-strength structural steel. 110 North Wacker and Salesforce Tower both utilize 65 KSI steel in their largest structural members, allowing columns to carry greater loads in less space. 150 North Riverside took it further, becoming the first building in the U.S. to use 70 KSI steel. It achieved its iconic narrow form using the largest rolled structural shapes in the world at the time. These giants were produced in Luxembourg and weigh a staggering 925 pounds per foot. But that wasn't the largest piece of steel at 150 North Riverside, because at its core, two of these sections were welded together. And finally, BMO Tower set the bar even higher, becoming the first building in the U.S. to use 80 KSI structural steel. Chicago may be known as the second city, but when it comes to structural steel, it has never been anything but first. The city that took the metal frame and showed the world what it could become. The first all-steel building, the first trussed tube, the first bundled tube, the world's tallest building, 70 KSI, 80 KSI, over and over again. And as structural steel continues to advance, Chicago's story is far from over.